For this next example, I'm going to have the volume of the solid bounded above by f of xy equals 10 minus 2x plus y, or the region enclosed by the curves of y equals 0 and y equals e to the x, where x is the interval 0 to 1. So let me just highlight different things. So this is my height of the volume thing I'm doing, whereas these other things are the base of what I'm being asked to do. So enclosed by this part and that part, and x is in the interval 0 to 1. X is in the interval 0 to 1. That all tells me about the base of the function. And so this is kind of my inside the integral. Yellow tells me inside the integral. Green tells me the area of integration. Okay, so let's draw my area of integration. So my area of integration is from y equals 0 to y equals e to the x from 0 to 1. So 1, 2, and change. Okay, so when y equals 0, that's that line. Y equals e to the x is that line. And so then we're limiting ourselves to be x equals 0 to 1. So we're kind of drawing it that way. That's our region of integration. Okay. So, let's see, is our function always positive in this region? So when y is the smallest, it could be 0. X is, yeah, it's always positive in this region. Okay. So then, that means we set up our integral. The best way to set up the integral is like that. I've got functions with regard to y, so that makes it easiest to put those as my inside integral. So it's best to have like lines, functions on the inside integral, and then only numbers in the outside integral. So here, and that number kind of corresponds to the domain. So the keyword being like x is in an interval is like a domain language. So that means it's definitely leading you to put 0 to 1 on the outside as the setup for this integral. And then we put 10 minus 2x plus y dy dx. So doing this integral, we get we integrate with respect to y, we get 10y minus 2xy plus 1/2 y squared from 0 to e to the x and dx. And so then plugging in 0 doesn't give me anything. So let's focus on the edx's. So then this is 10 e to the x minus 2x e to the x plus 1/2 e to the x squared is e to the 2x dx. Okay, and then let's split it up into like the easy integral and the hard integral. So the easy integral is going to be 0 to 1, 10 e to the x plus 1/2 e to the 2x dx. The harder integral is going to be integral from 0 to 1 of negative 2x e to the x dx, because we need to do integration by parts. So then u equals negative 2x, du equals negative 2 dx, dv equals, so dv equals e to the x, dx, and v equals e to the x. Okay, so this is equal to, let's solve our smaller integral, our easier integral. So then e to the x stays the same, 10 e to the x plus integrating that one, get the opposite of chain rule. So then 1/4 e to the 2x from 0 to 1. And then plus the UV part. So UV negative 2x e to the x from 0 to 1, and then minus integral from 0 to 1 of v du, negative 2 e to the x dx, and two negatives makes a positive. And so we have, this is equal to 10 e plus 1/4 e squared minus 10 plus 1/4 plus, when I plug in 0 there, it doesn't give me anything, but when I plug in 1, I get the negative 2 e to the x. And then plus, take that integral, and I get 2 e to the x from 0 to 1, which is just going to be 2e minus 2. So get all my e squareds together. I got 1/4 e squared. All my e's together, I've got positive 10 minus 2 is 8, but then plus 2 is again 10, so plus 10e. Then get all my numbers together. I've got minus 10 1/4 minus 2, so minus 12 1/4. So minus, I'll just keep it as a mixed fraction. Okay, and that's my answer.